So the next question will be cos of what? Cos minus cos 2 alpha. Cos 2x minus cos of 2 alpha. And it is whole divided by the denominator value is cos x minus cos of alpha. Cos of x minus cos of alpha. So the only difference in the numerator and denominator is that numerator you have 2x, denominator you have x. Numerator again you have 2 alpha, denominator you have only cos of alpha. So once again you can go ahead and use the same formula that I have used over here, cos 2x, cos 2 theta. We know this formula, cos 2 theta, right? Cos 2 theta is what? 2 cos square theta minus 1. So in place of cos 2 theta, we are having 2x. Accordingly, we can use the formula. So we know this formula, cos 2 theta. So cos 2 theta is what? 2 cos square theta minus of 1. So let us try to use this one. So if we try to use it over here, I will be getting the expression as cos 2x minus cos of 2 alpha divided by cos of x minus cos of alpha. So I'm taking this as the integral times of dx. So let me use the formula that I have. So if you use the formula, wherever you are having 2x, I can use this formula. Getting in place of getting x minus 1 to theta minus 1. Similarly, 2 alpha is there. In place of theta, you have alpha. So the formula will be cos square alpha minus of 1 whole divided by the denominator that you are having is cos x minus cos alpha. Is this clear how I have plugged in the formula? So if x is there, replace x. If alpha is there, you just replace alpha accordingly. Now further, you just open the brackets and 5. So you will be getting into dx you are having. Open the bracket. It is 2 cos square alpha minus of 1 minus 2 cos square. Sorry, this is x. The first term is x2 cos square x of 1 minus 2 cos square alpha. But minus of minus will become plus 1. Whole divided by the denominator you are having cos alpha cos x minus cos alpha times of dx. But if you try to observe over here, minus 1 and plus 1 will cancel out. You'll just be left out with integral of. However, in these two terms, you can observe that 2 is common outside. Write the value as cos square of x minus cos square of alpha. And it is whole divided by what you are having cos x minus cos of alpha times of dx. Now, if you further observe that one, however, 2 is a constant, you can take outside integral of it is in the form of a square minus b square, that can be written as a plus b into a minus of b. Hence, you can write cos x plus cos of alpha into cos x minus cos of alpha whole divided by no change in the denominator. The denominator will remain as it is. But if you try to observe the numerator and denominator are the same, you can just cancel out that one. So hence you are left out only with one term. So this cos x plus cos alpha. Better you can apply integral for the first term cos x and multiply that by dx. Similarly, apply integral for the second term. It is integral of cos of alpha times of dx. Now the reason why I have written cos alpha outside is because I'm integrating with respect to x. When I'm integrating with respect to x, this alpha will be a constant. Therefore, cos alpha will be acting as a constant. It's better to write outside. For example, if you're writing 2 times of dx, how do you integrate it? 2 is written outside and you write down integral of dx. So 2 is a constant, integral of dx will be x. This is how you write it. So in place of 2, you're having cos alpha as a constant. Therefore, cos alpha will be acting as a 2 only because it is a constant. Therefore, we are taking it outside. Now, if you try to integrate, we know the integral of cos x into dx. So integration of cos will be nothing but what? Sine of x plus the constant of integration c. So let us use that formula. It is nothing but sine of x plus this cos alpha as it is. Integration of dx will be x plus the constant of integration c. Or further, if you try to rewrite this one, 2 as it is, you are having sine of x plus it is better I write first x then cos of alpha plus the constant c. That will be the required solution.